In this video, we're going to learn what prime numbers are. Prime numbers are whole numbers which have only two factors, 1 and itself. What do we mean by factors? It's the two numbers that you multiply together to get another number. And those two numbers will be the factors. So for example, let's take 7. 7 is a prime number. Now let's have a look at 7 to see why it's a prime number. First of all, we'll look at the 1 times table. So 1 times table will be 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3, 1 times 4 is 4, all the way up to 1 times 7 is 7. And then if we look at the 7 times table, 7 times 1 is 7, 7 times 2 is 14, and so on. But we have our 7 here. So you can see we've got 7 in the 1 times table and 7 in the 7 times table. But there are no other times tables where you will get 7 as the answer of multiplying two numbers together, other than just 1 and 7. And that's what we mean by 1 and itself. So let's take some more examples. Here we have 2. Now remember, if a number is prime, it must have two factors, 1 and itself. That would mean that this would have the factors 1 and 2. So you can see that obviously 1 will be in all the cases, but 2 is the only other times table we can look at. And of course 2 does have the 2 times table in it. And so this makes number 2 a prime number. But what's so special about the number 2 is that it's the only even number that's a prime number. Every other even number will have 2 as one of its factors, in addition to itself and 1, which would mean that it wouldn't be a prime anymore, because prime can only be two factors, 1 and itself. So here we have 2 as a prime number. The next example is 29. Again, we know it'll have 1. We'll know it'll have 29. But if you think about any other factors, there are no other factors that, if you multiplied it together, would give me 29. And also the last example here we have is 67. And again, we have 1 as a factor and 67 as a factor, but there are no other factors that will go into 67. Now it's your turn. Okay, the first example here is 3. The factors of 3 are 1 and 3. There are no other factors, and since there are only two factors and this is a whole number, then 3 is a prime number. The next example here we have is 2065. Now, if you think about the 5 times table, 5, 10, 15, 20, 25, 30, and so on, you will notice that there's always either a 5 or a 0. 5 or a 0 at the end. So here we have a 5 at the end, which means that 5 is a factor of 2065. So that means that other than 1 and 2065, 5 is also another factor. Therefore, it's not just two numbers, 1 in itself. So that means that 2065 is not a prime number. Number 71. So here we know that 1 and 71 will be prime, but are there any others in between? Well, it can't be an even number, so 2, 4, 6 and 8 will not be factors. So we can look at 3, for example. How many 3s are there in 71? 3 times 2 is 6, there's 2 with a remainder of 1, and 3 does not go into 11 without a remainder, so 3 is not a factor. The other one that could be would be 7, but 7 times 10 is 70, and we've got 71, so that means that 7 is not a factor. So since we only have two factors here, 71 is a prime number. The next example, 1.9. Well, straight away we know this is not a whole number, so this will not be a prime number. Then we have here 126. Again, this is an even number. The last number is even. So we know all other even numbers other than 2 are not prime because they all have a factor of 2. So that means that 126 is not prime. And then we have 63. Well, 3 is an odd number, so we could look at other factors other than 1 and 63. And it looks that 3 will go into 63 with no remainder. So there are 2 3s in 6 and 1 3 in 1. So exactly. So 21 is also a factor. So that means that 63 is not a prime number. And if you want to know how you can locate prime numbers easily in numbers between 1 and 100, go and check out my other video on finding prime numbers easily. I hope you like this video. Don't forget to share, like and subscribe. See you in the next video. Bye.